Hello, everyone, and welcome to Debugging Drama with Kubernetes Operators, test-driven development to the rescue. I recently took a trip to a land of bugless development. It was beautiful for Kubernetes operators, and I just want to show you some of my journey, a little bit of my journey, and hopefully this will help you in your daily endeavors developing Kubernetes operators. Now let's go a little bit through the agenda that we have. So we do have an introduction. I'm going to just talk about a little bit of testing development, how it helps the whole team and not just yourself. We're going to go through a small problem that we're going to try to solve. We're going to define some scenarios, and eventually we're going to put it all together in a controller. We're gonna find a bug and solve it with test-driven development, but it's gonna be a little bit different than what you're used to. Uh, it's gonna make a lot more sense once we get there. And then we have a little bit of best practices for test-driven development. I'm just gonna show you just a few things that you can follow through and to make your test-driven development journey a little bit easier for you. And now at the end we can well, of course we can have a Q&A. All right, so first let me introduce myself. My name is Daniel Prado. I'm a director of software engineering manager at Veritas Automata, and I'm a coffee enthusiast, and I'm a Formula One fan, of course. So yeah, that's me. And just as a bit of an introduction, let me tell you about what test-driven development is. It's not about tests. Shocking, really, but because it's right in the name, right? But it's actually a tool to communicate with your team. Yes, that's right. It's a tool to communicate with your team, and not just the developers, not just the computer science people, but also the other non-technical people that are within your company that are also very valuable. And usually they have very good ideas and novel approaches because they're not tainted with the software development brain. They actually have their brain in other areas, so they're able to give you more um, better solutions, even maybe for your implementations without having to go technical, which is amazing. Usually in companies, there's this gap where non-technical people and technical people cannot get together to discuss a problem. And test-driven development gives you this opportunity of defining behaviors, of defining scenarios, and different things that will essentially help you define the goals and requirements that you have to meet. And then, of course, this gives you a very generic language to communicate with, again, with the rest of your team. And not only that, but even to your clients, if that makes sense. Now, let's present the problem. The problem is we want, or the company wants you to build an easy way to transform markdown into a PDF file, and they want you to use Kubernetes for this. They want you to create a CRD that people can easily get in, type down some configuration, and just get this done to transform the markdown files into PDF files. So this, what you're looking at is what the CRD would look like. Very simple, very generic. You can just see that the spec is essentially just the document name and the text. Of course, right now at this moment, we do not have a controller to go with it. We're just trying to define exactly what we want. So this is part of the design process. Now, if you move forward to the next one, we can see here that we're going to be, essentially what we're going to be creating is a feature, really, which is the PDF document controller. For this feature, well, you can see a couple of things. For instance, we have a grand thing, which is when creating a PDF document resource, which is this scenario, right? So there's a scenario where people are going to, this is a very basic scenario where people are going to be creating the PDF document resource within the Kubernetes. Then it should create a PDF file based on the given text. There are some key words here that we're using, and this is what I want you to take from this is that this text that we're seeing here on the right really is representing a lot what the test-driven development is about. This will give you the tools to talk to your team as to what exactly they're going to get, uh, and to your development team as to exactly what they want or what they need to implement really. Now, there are some keywords, as I said. Uh, the most common keywords are given, when, and then. In this case, we're using it. So given gives you context as to what's going on. It could be that something has been created so far, and then for that thing that's been created, you're going to modify it, or the context is that it doesn't exist and you're creating it from the get-go, which is that when you're seeing here when creating a PDF document resource, although this is really an action, right? The context is that there is no context really. There's nothing. Or the context is that there is no file already created. We're going to create one from scratch. So when this action takes place, which is creating a document resource, a PDF document resource, then it should have a desired outcome, which is the PDF file should be created based on the given text. Now, you may see this as, well, yeah, that makes sense. It looks good, but how do I translate this to code? Well, really easy. Yeah, that's code. It's essentially the same thing, which with a little bit more of it's everything in Go instead of a chart. But now this is implementable code. You can actually copy this and paste it. But now I hear you ask, well, yes, that's cool, but that's an empty test. It's not testing anything, right? So what are you talking about? Well, bear with me. There are rules to test-driven development. Yes, there are rules. I'm sorry, but yes, there are. So there are three. There's just three. Don't worry about it. The first rule is write no more of a unit test than sufficient to fail, meaning that what we got before is actually a pretty good test. It's a failing test because it's empty, right? So great. First rule, we're golden. It's a failing test, but at least it's giving us where we want to place the code within the project. Now, if you are using something like Cube Builder, your controller file will be already there. Your some other like the CRD file is going to be there. The types file is going to be already there. So you're going to have a lot of scaffolding already there, but this test file doesn't really exist. If you create it and it's empty, it should fail. And again, that's a really good test. It's confirmation that your test file is running. It's actually being run right now, and it can be accessed. And now if you make changes to it, you're going to be actually testing things. So that is a good failure. Now, moving on, we have the execution plan. Exactly what is that we're going to build. Now that we have the context and the things that we want in the test, again, the context and the then statement or the it statement, the thing that we want to do, the outcome that we are expecting. Now we can talk about the execution plan. And this is essentially just reasoning about how the solution is going to look like. And you're going to test for the solution, not for the problem, for the solution. You're designing the solution. Now, essentially, if you stop for a little bit and think about and reason about what you're doing right now with your code, you're going to stumble upon that what you want to do is create a CRD, create a controller that takes that CRD and does some actions, and then, well, perhaps a job. A job is a very good thing because it's gonna tell you, essentially, the job is gonna be the one that does the work of transforming the markdown text into the PDF file that you're actually expecting. So you have the three things that you want to build. Good. We had the execution plan. We now know, or at least we have the things, the components that we want to build for our controller within the operator that we already have initialized in our code. Let's take a look at the specification of the CRD. Now, this is part of the code that you're going to be placing in your test. And essentially what it's doing is, well, you can see it looks an awful lot like the original CRD that we saw a few slides ago. Um, it has a main difference though. It's in Go now. It's not a YAML file. It's not a configuration file. It's a Go file. You can see instances of the V1 core API for Kubernetes. You can see now another API that we created essentially for the operator, which is called Kubernetes VA-COM V1, and that's the API that we're going to be building essentially. The PDF document spec already exists, but if you write this code, and this is the first line, these are the first lines of code that you write, this test will fail. In fact, it will not compile. Failing to compile is a good test. It means there's something missing that you have to put in there for it to compile. It'll give you squiggly lines around the document name and text within the spec section of this PDF doc. And what we're going to do now is we're going to, after this, when we have this error, we're forced to go to the types file and add these types there, right? So that is a very normal thing when you're doing a controller. But now you have a test that is telling you what to write. So it's good. It's doing its job. Perfect. Moving on. We have the other two components that we needed to define, that we needed to design, and this is the code that designs the implementation for the PDF controller and the PDF job. Now you can see here that we have, we're expecting that the PDF doc that we just defined in the other slide, the previous slide, when that is being used to create to create the resource essentially, it should succeed. Moving past that line, we perform a lookup for the PDF document, we perform a lookup for the job, and you can see here another piece of design for the implementation, which is that the PDF document name has to have a dash job at the end. Or rather, the name of the job should have a dash job at the end, using the PDF document name that we define from within the PDF doc YAML file, or rather a resource. So you can see here that we're starting already to define and to design this whole process. Moving on, you can see that we have a couple of references for the PDF doc, for the created PDF job, and then we perform a couple of checks and we wait for them to be created. Now, this is because on KubeBuilder, you're using the mtest. Essentially, it's building up like an etcd server, database server, and it's building up enough of a Kubernetes setup around your tests so that it behaves the same way as if it were already deployed on a Kubernetes cluster, which means you don't really need a Kubernetes cluster to develop your code. You don't really need to execute your code. You can just execute the tests. And if it works on the tests, it's 99.99% sure it's going to work on your Kubernetes cluster, unless it's some kind of weird implementation of Kubernetes. But that's another story. Now, this test right here will absolutely and 100% completely sure will fail. Because of course the job doesn't exist. There's nothing created in the job. There's nothing running on the reconciliation within the controller. Of course, the controller and the reconcile function, they do exist right now, but they're empty at this stage. So there's nothing being executed there. The coverage is going to be 0%, and nothing's going to get executed, right? Cool. So how do we fix this? Well, very easy. We're gonna go through another rule of test-driven development, and this is really important. Remember that the reconciliation right now it's empty. There's no implementation, and the next rule is essentially write production code only to pass a failing unit test. So when the thing that you have to get in your mind is you have to switch, and this is really weird to say, and I'll give you the reference for these rules and the cycle of TDD and everything else, but essentially you have to use the least amount of neurons in your head to run your code or to create your code, because that's going to save processing power of your brain. You're going to concentrate just on the little thing that you're trying to solve, just on a very small thing that you're trying to solve. You're not going to concentrate on the whole thing because it's too much. So having said that, uh, thanks to these two, thanks to the first rule, now we have a design. Now we have something that we want to implement. Now we know the name of the job. It already has some kind of pattern that we want to respect. We know that we need to create a job actually that executes this process, and that essentially that's what's going to happen, right? So now we're going to write production code that makes this test pass, but only this test, only this part. It's going to look incomplete, but it's going to work. So, of course, I removed all of the things around this code, and I extrapolated all the functionality within this function create job. As you can see here, I'm using the PDF document reconciler from the controller. And you can see here that I have an image which is called pandoc core. It's just an image that gets some other formats and turns them into PDF. I think it uses LaTeX. You could use Markdown. You could use some other stuff. But for our purposes, what we're going to do actually is we're going to turn our Markdown into base64, and just to make it easier to transfer the text around as a variable, and just formatting and templating all of that. It's going to make it a lot easier to just have a single base64 text, and we have that over there. And you can see here that also we're creating a job. This is the third variable that we're creating, is the actual job. So we're using batch v1. So the v1, the version 1 of the batch API for Kubernetes and the API API machinery. So now you can see here that we're defining the job. We're defining the name that we remember that on the test we said that the name of the job has to be PDF. The name of the PDF document dash job. Well, we have that right now, meaning that if we create more PDF resources, more jobs will be created on top of because of them, and they're all going to work completely isolated from each other, which is good, I think, for now. Depending on what you'd want to do with this. But it's using a namespace already. And well, right now on the specifications of the job, well, it's really long, and it's I think it's beyond the scope of this conversation that we're having right now. Because again, it's just defining a job. It's really easy. It's just a container and just some bash functions, and it's not really it's again outside of the scope of this conversation that we're having right now. And just return a job, and that's it, right? So you call this function from the reconcile function of the PDF document reconciler, and you're good to go. So now we can see the three components that we designed previously being actually implemented within the code. Now, this takes us to the third. It takes us to the third rule for test-driven development, which is write no more production code than necessary to pass the one failing unit test. Now, here's the thing: make sure that when you're doing this, when you're doing test-driven development, you don't try to be smarter than you have to be, right? Meaning that don't try to do much more than the unit test is asking you to do. Even if you feel like you can go further, you can go faster, you can go, you know what, I can write more of this. You don't really have to do it right now at this stage, and you have to hold yourself from doing it. If you're a developer that has never done test-driven development, it'll be really hard at first. It'll get better as you get more confident with the whole process of test-driven development. But essentially, you have to promise yourself that you're not going to write of a production code that is necessary to make the test pass And of course, that means also, well, try not to break the other tests that may already exist over there. So yeah, that essentially is how you implement test-driven development on a Kubernetes operator for when you're doing your controllers in this case. Now, let's go back a little bit into the feature. And well, you may say, well, but this is an incomplete implementation. And yes, you're absolutely correct. It's an incomplete implementation because it's not looking at the entire spectrum of things that could happen to a controller or to a CRD. It could get deleted, it could get invalid values, it could get a lot of things. So for instance, one of the things that we're not testing here for is what happens if the text is empty. Well, it should fail, right? Yeah, it should fail. Or if it's getting some kind of, you can run some security tag things there to make sure that it doesn't have any sort of security holes within the text, that nobody's trying to hack the system or whatnot, or to exploit anything. If it has some text that it looks like they're trying to exploit something in your Kubernetes cluster, then you can stop it right there. So here, what you can see is, if you compare this to the other slide where I showed you just one single scenario, now that you can add more scenarios using the same context. You can have more if statements in your code within the same context of creating a PDF document resource. It's really important that that you follow the 3 rules to create your things. And now you can see here, this is the part where a bug would occur. And this is where, okay, what happens if the text is empty? Well, it should fail, right? So you can actually go ahead, create another test for this, create the PDF doc with an empty text, and just see it fail, right? And what failure you want, what error do you want to showcase to your users, so that it conveys the urgency of adding actual text. But yeah, so this is more or less what you can get. If you don't add this test and your user wants to use your resource, your CRD that you just created, they can still do it, right? So if that controller that we just created, it works. If you compile it and put it in a Kubernetes cluster, it works. I know because I just did it on my own Kubernetes cluster locally on my laptop, and it does work. The problem is when you start going through the rest of the cycles, like deleting the PDF document, for instance, you have to remove the job. You have to make sure that you're doing a few operations better, that you're cleaning up those PVCs that you just created on the create job reconciliation part of it. So those are bugs. Those are actual regular bugs. Hey, what happens when this gets deleted? Oh, I forgot to do that. All right, I'll go ahead and remove the job. I'll go ahead and remove this. And, oh, right, the PVCs and the persistence volumes and the volumes. And yeah, we have to delete those. So instead of waiting for the bug to appear, when you go about doing your controllers this way, you're essentially looking ahead and defining what sort of failures you may get. Okay. And this is exactly what this gives you. It gives you the tools to define what sort of failures you may get in the future. And you don't really have to think about all of them at once. You can go one by one. It gives you another benefit, which is that honestly, you can just go ahead and stop in the middle of whatever you're doing, go do something else, and come back to your code, and you know exactly where it is at any given time because you have all of the tests that you've written so far that are passing, and you know where the last test, the failing test is, which is the one that you have to make pass, either because you didn't complete writing the test or you didn't complete the implementation of it, and you know exactly where you are. It gives you enough context, in a very, very small context, actually, to keep going where you left off last time. So it's a very good tool for developers overall. Now, there is one more thing that I left aside, but just because I didn't define it, what I'm going to show you right now is what is called the cycle of test-driven development. It may look different than others you may encounter, but I just wanted to make sure that this process was well defined. So, for instance, the first thing you do is the thing at the top, which is to think and you write the test case. You think about the solution that you want to implement. Now, the thinking part, that can happen with your team. It doesn't have to be you alone. And actually, if you do it alone, it's much worse. It's very bad for you. Try to get your teammates to work with you. Try to get the product people to work with you, to think about the solution that you want to build. Don't think about the problem. Don't think about implementation. Don't think about how hard it's going to be to implement that. It's too hard. It doesn't matter. What you have to do is think about the solution first. Talk to essentially what your customers are going to be, right? And think about them and how they're going to use your tool. How is that solution going to look like? Write your test cases based on this. And again, the problem is that it's this word test. It's not really it is a test in the sense that it's actually running code against another piece of code until this code passes. But it's really a hypothesis that you're building. So you're building this hypothesis, these test cases, and you're writing them down. Once you have them written down, you know exactly, not only exactly how far ahead you are with the things that you have to deliver, but also you're just going one by one, very in a very simple way. Anyways, you write your test cases, you think about it, then you go into your IDE or code editor, you write the failing test. Then you go into the implementation code and you make it pass. You write your code, but enough code to make the new test cases pass. Bear that in mind. It's just a test case that you're writing in that moment that you have to make it pass. Of course, take into account all of the old test cases. Try not to break them in the process. And once you have everything running, well, essentially the next step is to refactor or to implement the next test case. Now, refactoring is it's a tricky thing. So it's not just refactoring of the implementation code, which, by the way, if you do this process, refactoring becomes very, very, very easy task. Refactoring becomes a very easy task, and this helps you a lot with that. But also, refactoring means refactoring the test cases or refactoring the test code, because you're going to be able to write your test. And once you look at it and it's running, you can look at it and say, okay, I can make a commit right now, and I can start tweaking my test cases to make it look better. For instance, if you're performing the creation of the PDF doc, for instance, in our previous case, you can just have that PDF doc, put it on the before each statement, and have that run before each of the tests, and just modify it a little bit for each individual test cases. Or rather, you can reset the PDF doc on before each, and then within the test case, you can modify it ever so slightly just for the test case that you want to run. For instance, deleting the text and seeing what happens there. So yeah, that's the streaming development for you. This is all of these rules and all of these things are for not just for Go, not just for Kubernetes operators and controllers, but also for any sort of coding that you're going to do ahead in your development life. So go look for Uncle Bob and his talks. Those are really good. And he has a talk for test-driven development that is really, really good. It's going to look bonkers. I promise you, it's going to look bonkers. If you've never done test-driven development before, it's going to look totally insane. You're going to think, what is this guy doing? And then at the end, everything is going to click and you're all going to have a great time there. And with that, thank you so much, and I hope you have an awesome day. Thank you.